Hi friends, welcome to TechnoStube. In this video, we are discussing some moderate level MCQs and some problematic MCQs. This will be helpful for the candidates who are preparing for HIL exam, BARC, GATE exams and other competitive exams. Okay, let's begin start. Sensible heat. Sensible heat is the heat need to. This question first we need to know what is the sensible heat. We know that sensible heat is the energy required to change the temperature of a substance with no phase change. Okay. So from the option, we can see that the option B, the change the temperature of a liquid or vapor. That is the right answer. Next, air flows over a 10-meter long plate. The transition from laminar to turbulent flow takes place between Reynolds number of 2.5 into 10 raised to 6 and 3.6 into 10 raised to 6. What is the maximum distance from the front edge of the plate along which one can expect laminar flow in the boundary layer? The free stream velocity is 30 meter per second and kinematic viscosity is 1.5 into 10 raised to minus 5 meter square per second. Okay. In this question, first we need to understand the fluid flow over a flat plate. For a fluid flow over a flat plate, in the laminar condition, the Reynolds number is equal to rho v into x divided by mu. Rho is the density, v is the velocity of the fluid, and x is the distance from the front edge of the plate, and mu is the dynamic viscosity. This question already given the kinematic viscosity, that is the dynamic viscosity divided by density of the fluid, that is given, already given. The velocity also given, and the Reynolds number. The Reynolds number, in this case, we need to consider for maximum, we need to consider the laminar flow. For the laminar flow, we need to consider the Reynolds number is 2.5 into 10 raised to 6. Okay, so we can substitute these values to the equation. From that, we can find the x value. That is x value, that is the distance from the front edge of the plate that we can calculate. From that, we will get as 1.25 meter. That is the right answer. In brassing process, the melting takes place in brassing process, the melting takes place only in the filler material. Next, a diesel engine having the compression ratio of 16 and a cutoff ratio of 2.6. The clearance volume of the diesel engine is 45 cubic centimeter. Find the volume of the gas when piston has completed 40% of the compression stroke. Okay. For doing this problem, first we need to draw the PV diagram for that. From the figure we can see that V1, that is V1 or V4 equal to V4, that will be equal to the total volume of the cylinder, and V2 or Vc is the clearance volume. In this question, the compression ratio is given, that is the compression ratio is the ratio between the volume before compression and the volume after compression. So that is given, that is 16. From that we can find the total volume, that will be equal to Vc into 16 equal to 720 cubic centimeter. They are asking the volume of the gas when the piston has completed 40% of the compression stroke. Okay. That means the remaining volume, that is the remaining volume will be 60% of the stroke volume plus the clearance volume. That will be equal to, substitute this value over to the equations, and then we will get to 450 centimeter cube. That is the right answer. That is the volume. Three large plates of same are kept parallel and close to each other. They are considered as ideal blank surface and have very high thermal conductivity. The first and third plate are maintained at a temperature of 2T and 3T respectively. The temperature of the middle plate under steady state condition. Okay, for this problem, at steady state condition, that heat transfer will be same. Heat transfer rate will be same. Or considering, if you are considering the second plate or middle plate, heat absorbed by the plate will be equal to heat released, heat radiated from the plate, from the second plate. That will be same. Okay, that's the radiation heat transfer. The radiation heat transfer falling to the second plate will be equal to the radiation heat transfer from radiating from the second plate. Okay, that will be equal to sigma t raised to 4. Sigma t raised to 4. That will be equal to sigma t raised to 4. In the case of second plate, the falling will be equal to sigma into temperature of the third plate, that is 3T whole raised to 4 plus sigma into from the second plate, from the first plate, that will be equal to 2T raised to 4. That will be equal to energy transferring from the second plate, radiation energy transferring from the second plate, that will be equal to sigma T2 raised to 4. That is having two surfaces, two faces, so multiplied with 2. From that we can find the value of T2, that will be equal to T into 97 by 2 whole raised to 4. That is the right answer. In quick return mechanism, if the length of the extension link on which tool is provided and is pivoted is 150 millimeter, when then what is the length of the stroke? Okay, in quick return mechanism, the length of the stroke will be equal to 2 times of the length of the extension link. Okay. That is the relation between length of the extension link and the length of the stroke. That will be 2 times of the extension link, that will be equal to stroke length in quick return mechanism. So the answer is 300 millimeter. Next, vibrating system consists of a mass of 50 kg, a spring with a stiffness of x kilonewton per meter, and damper. The damping provides is 20% of the critical value. Damping frequency is 24 radians per second. Then find x. Okay. For better understanding, we need to draw the figure. Okay. Spring damper system we need to draw. And then here the mentioned the damping provides is 20% of the critical value. That is the damping ratio or damping factor is given. Damping factor eta is given. That is 0.2. That is 20%. They are already given. Okay. We need to find the spring index K or X. We know that omega d also given. That is the damping frequency omega d is equal to omega in root 1 minus eta square. So substitute the omega d value and eta value, then from that we can find the omega n value. Omega n will be equal to 24.5 radians per second. We know that for a spring mass system, omega in natural frequency omega n is equal to root of k by m or x by m. Okay, so root of k by, from that we need to substitute the value of omega n and mass of the substance. From that we can find the value of k. K will be k or x equal to 30 kilonewton per meter. That is the right answer. In an inward flow reaction turbine, Inward flow reaction turbine. Inward flow reaction turbine. In an inward flow reaction turbine, water enters through the outer periphery and flows towards the center of the wheel. That is C. That is the right answer. A fluid having Prandtl number equal to 6.5 or 6.5 or at 18 degrees Celsius. The thermal boundary layer thickness is 8 centimeter. Find the boundary layer thickness of all the fluid. For a fluid having Prandtl number, first we need to know the relation between Prandtl number and the thermal or boundary layer thickness. That is the boundary layer thickness. The ratio of the boundary layer thickness and the thermal boundary layer thickness will be equal to Prandtl number the whole raised to 1 by 3. Okay. Here Prandtl number is given and the thermal boundary layer thickness also given. From that we can find the value of boundary layer thickness, that will be equal to 14.96 centimeter. That is the right answer. Raw material for all iron and steel product is. Raw material for all iron and steel product. Raw material for all iron and steel product is, yes, pig iron. Pig iron is the raw material need to make all type of iron and steel. The three main raw materials used to make pig iron for primary steel production in a blast furnace are the processed iron or coke and limestone. Okay, these are the main raw materials. Okay, these are the main raw materials to make pig irons, that is iron ore, coke and limestone. Okay, the right answer is pig iron. In a reaction turbine, the draft tube is used. Okay, draft tube. Why draft tube is using in reaction turbine is the primary function of the draft tube is to reduce the velocity of the discharged water to minimize the loss of kinetic energy at the outlet. Okay, primary function of the draft tube is to reduce the velocity of the discharged water to minimize the loss of kinetic energy at the outlet. So that we can increase the effective total head, that is minimize the kinetic energy, that is the potential energy will increases, so the automatically the increases in effective head also. So the right answer is to increase the effective head of the water. Which of the following is true with relative to basic thermodynamics? Okay, first we okay. In free expansion, since vacuum does not offer any resistance, there is no work transfer involved in the free expansion. Okay, correct. In free expansion, work transfer is equal to 0. In B equal to 0. 100% heat cannot be converted to work. Yes, correct. And 100% work can be converted into heat. Okay, it's possible. It depends on the second law of thermodynamics. Yes, correct. Then heat transfer in all finite temperature difference is all heat transfer processes are irreversible processes. That's also right. So the out of this true relate. Okay. All these are correct. All the statements are correct. Which of the following is acceptable phrase of Kelvin Planck's statement of the second law of thermodynamics? What is Kelvin Planck's statement for the thermodynamics? That is, it is impossible to construct a device which operating in a thermodynamic cycle convert all heat input into work output. Okay, that is impossible. Converting all heat input to output work, that is impossible. That is 100% efficiency is impossible. Okay. Okay. In this case 100% efficiency is not possible, and convert all heat input into work output is also not possible, so that the engine need to be reject some heats. Okay, that is the right answer. An engine has to reject heat. A porter lifts a luggage of 15 kg from the ground and put it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage. Okay. So in this question, the work done will be equal to the potential energy, that is mgh. Equal to potential energy, that will be equal to mgh. All the values are given. From that we will get answer 225 joule. Tail rod of 200 millimeter length held between the two rigid supports is heated by 35 Kelvin. The coefficient of thermal expansion is 15 into 10 - 6 per Kelvin, and modulus of elasticity is 200 gigapascal. The stress induced in the rod is, okay. The stress induced means thermal stress. The thermal stress is equal to alpha E into delta T. That is the equation for the thermal stress. Here alpha is given. Alpha is the thermal expansion, coefficient of thermal expansion, that is given, and change in temperature, that is also given, that is 35 Kelvin, and the Young's modulus E 200 gigapascal, that will be equal to 200 into 10 to 3 megapascal. So that's also given. From that we can calculate the value of thermal stress, that will be equal to 105 megapascal. Next, a reversible thermodynamic device operates between the temperature limit of 500 K, 1100 K and 300 K and produces 1000 kilojoule of work. If it absorbs 500 kilojoule of heat from thermal reservoir of 500 K, find the heat exchanged with 300 K reservoir. Okay, first assume A is the amount of heat from 1100 K and B is the amount of heat from 300 K. Okay. Using the energy balance equations, that is heat transfer will be equal to work transfer. Okay. The heat transfer from the source, A plus B plus 500, that will be equal to 1000, and A plus B will be equal to 500. And apply the Cauchy's equality for the reversible cycle. That will be equal to the heat Q by T. The sum of the all Q by T equal to 0. That is A by 1100 plus B by 300 plus 500 by 500. That will be equal to 0. From that we can find the value of B, that will be equal to minus 600 kilojoule. That means the 600 kilojoules of heat is rejected from that 300 kilojoule 300 Kelvin source. Okay, that is the right answer. That is a 600 kilojoule is rejected by the device. Minus 600 is the right answer. For a constraint mechanism, chain having 6 links and no higher pair, the relative motions among the link is also assumed to have a degrees of freedom of 1. Find the number of binary joints. Okay. In this question we need to know that the degrees of freedom and relation of degrees of freedom and number of binary joints and higher pairs. The equation for that is the degrees of freedom is equal to 3 into L minus 1 minus 2j minus h. Okay. Here number of links is given, that is 6. Number of binary joints we need to calculate, and higher pair is h, that is given, that is 0. From that we can find the binary joints j equal to, that is equal to 7. Okay. Thank Thank you.